Question number 51. Meena opens the mathematics puzzle book and notices that the product of two facing page numbers is 1332. Question is, what is the sum of these two page numbers? Note that all pages are numbered consecutively. So the idea is here the product of two facing numbers. Say one number is x means the other number should one number is x means the other number should be x plus 1 or x minus 1. Page number should be like that. If it is the this is the book. The left hand page number is x. The right hand page number is x plus 1. Or if you take the right hand page number is x, the left hand one is x minus 1. So here the idea, in order to find this, the sum of these two numbers. First of all, we have to identify these numbers. So our goal is to identify the number x. So the idea is we have to find the square root of 1332, which is slightly larger than 36, bigger than 36. However, it's smaller than 37. So the square root of 1332 lies between 36 and 37. So those numbers are 36 and 37. 37 plus 36. So question is sum. So sum of these two numbers is 7 plus 6, 13. 3 plus 3, 6, 6 plus 1. So the answer is 73 E. So this is the question number 51. Question number 52. A regular hexagon has an area of 432 centimeters square. Regular hexagon. So the hexagon I draw like this. All the six sides, regular hexagon means all the six sides are of equal length. This area is given. So we know that the area of the hexagon is given by, I label area as A, and 3 into square root of 3 by 2 into A square. When the side length is A, the area of this regular hexagon is given by 3 root 3 by 2 A square. Question is, what is the area of a square in centimeter square if the square has the same side? So I take the side length of the hexagon is A. So according to the question, the length of the square is also the same side length A. So the question is, what is A square? Because the area of the square is given by A square. So the question is A square. So this area of the hexagon is given as 432. So from here onwards, we can find the A square. When you make A square as subject, that will be given as 432 into 2 by 3 root 3. When you can divide this 432 by 3, that is 144 into 2 by root 3. So the hereafter we are going to multiply by root 3 the numerator as well as the denominator. And you multiply by the numerator and the denominator by the same number, there is no change. So here in the denominator root 3 into root 3, that is 3. So 144 by 3 into 2 root 3. Now this 144 by 3 is 40, 48, 48 into 2 root 3. That is equal to 96 root 3. So the answer is C. Next is 53rd question. What is the value of square root of 21 minus 8 root 5? So here the idea is we are going to make this 8 as 2 into 4. 2 into 4 is 8. So then this 4 is taken inside the square root. Then that becomes 16 because 4 square root of 16 is 4. 4 can be written as square root of 16. So 16 square root of 16 is 4. So this one can be written as 2 times square root of 16 into 5. 21 can be written as 16 plus 5. So now I am going to write 16 as square root of 16 holding square. Similarly, 5 as square root of 5 holding square. Then negative 2 times this one. So this is the expansion of square root of 16 minus square root of 5 holding square. Outside we have another square root. So square root is power of half. So 2 into half is 1. So that is equal to square root of 16 minus 5. Square root of 16 is 4. So the answer is 4 negative square root of 5. The answer is E. 54. Question number 54 is ABCD is the rectangle such that AB is equal to BC. So AB is equal to BC. So this means I take AB as 2A, then BC also 2A. The midpoints of the side CD and AD are E and F. So the total length is 2A, therefore AF is equal to FD is equal to A. Similarly, D is equal to EC is equal to A. Now the question is what's the ratio of the areas of unshaded region to the shaded region? So the shaded region is there are two areas. So one is this triangle ABC. That area is given by half into its length is 2A. Then BC is 2A. And this perpendicular distance AB is 2A. Therefore, the area of the triangle ABC is 2A square. Similarly, this area of the small triangle DEF half into A is squared by 2. So the total shaded area is given here 2A squared plus A squared by 2, that is 5A squared by 2. In order to find the unshaded area, I find the total area, that is the total area of this rectangle. It's 2A into 2A, which is equal to 4A squared. Unshaded area is given by total area minus shaded area, that is this area. That subtraction gives the area of this portion. That is equal to 3A squared by 2. The question is the ratio between the areas of unshaded region to the shaded. So unshaded to the shaded. Unshaded is 3A squared by 2. Shaded is 5A squared by 2. A squared by 2 is a common one. Therefore, the ratio is 3 is to 5. So the answer is C. Question number 55. The average of four distinct integers is 57. So I take those four distinct integers as A, B, C, D. There are four numbers, so we have to divide by 4. That is the average of these four numbers, which is given as 57. So we take 4, we multiply by 4 both sides. That is a plus b plus c plus d is equal to 57 into 4 is equal to 228. Now they have given the largest integer is 75. So 1 of A, B, C, D is 75. So when we subtract 75 from 228, that is 153. So now we have another three numbers. So the largest integer is 75 means I take the other two integers 73 plus 74. And the sum of these two numbers is 147. So these are the possible largest values for the remaining values 73, 70, 70. So 75 is the largest one. So only one number has to be found. So that should be the smallest possible value of the least integer that will be obtained when we subtract 147 from 153. That is 6. 153 minus 147 is 6. The answer is 6. A. Question number 56. If 3x minus 11y is equal to 2 and xy less or equal to 300, then how many positive integer solutions are possible? So I'm going to make x as a subject in this expression. Then x is equal to 3x equal to 11y plus 2. Therefore, x is equal to 11y plus 2 by 3. Here, the question is how many possible positive integer solutions are possible. So x is an integer if y takes these values. So if you take y is equal to 1, 11 plus 2 is 13 by 3 is not an integer because 13 is not divisible by 3. So when we put 2, 11 into 22 plus 2, 4 by 24 by 3 is 8. So y is equal to 2. Then the next possible value for the integers x, y is equal to 5, y is equal to 8. Every values are added by 3 here. So the last possible value is y is equal to 80. When we put 80, that is 880 plus 2, 882 by 3. That is equal to 2, 294. So that is an integer, and also 294 is smaller than 300. When we put 81, that is not divisible by 3. Similarly, when we put 82, that is bigger than 300. So according to our question, the x and y should be smaller than or equal to 30. So the highest value of y is 80. So now how many uh, solutions are possible? In order to find that, I'm going to use that formula uh, identification of number a plus n minus 1 into d, because this is the arithmetic progression. Arithmetic. So n minus 1 into d. Here a is equal to 2. The first term is 2. We have to find what is n. N minus 1. The last term is 80. The last term is 80. D is equal to 3. So the difference between each term is 3. So if you simplify this, that is 3n minus 1, which is equal to 80. So 3n is equal to 81. Therefore, n is equal to 81 by 3. So that is 81 by 3 is 27. So the answer is 27, which is option B. Question number 57. Consider a sequence of numbers given by the expression 9 plus 2n minus 1 into 4. That is equal to 9 plus 2n into 4, 8 and negative 4. That is equal to 8n plus 5. N varies from 1 up to 85. How many of these numbers are divisible by 7? Question is 7 divides 8n plus 5. For n is equal to 1 up to 85. So when n is equal to 1, this is 13, which is not divisible by 7. Similarly, when we put 2, 21. 8 into 16 plus 5, 21 is divisible by 7. So the first possible value is n is equal to 2. Similarly, when we put n is equal to 3, 24 plus 5, 29 is not divisible by 7. N is equal to 4, 32 plus 37 is not divisible by 7. The next possible value is n is equal to 9. That is 9 into 8, 72 plus 5, 77, which is divisible by 7. So here the difference between n is 7. When you add 7, the next possible. So the next one is n is equal to 9 plus 7, which is 16. 8 into 16 is 128 plus 5 is 133. This is divisible by 7. 7 divides 133. So the possible values of n is 2, 9, 16, 23. We have that 7 plus 7, 30, 37, 44, 51, 58, 65, 72, 79. When you add 7 with 79, that is 86. That is bigger than 85, so that is not possible. So the last possible value is n is equal to 79. So here 3, 6, 9, 12. So the answer is 12. There are 12 possible numbers. So the option C is the answer. Question number 58. When a positive integer is divided by d, the remainder is 241. So here, when a is divided by d, the remainder is 241. So it can be written as a is equal to d times some multiple k1 plus 241. This is the remainder. Similarly, when 2a is divided by d, the remainder is 112. So similarly, we can write 2a is equal to d times some multiple k2 plus 112. So to make the first expression in terms of 2a, I'm going to multiply by 2 both sides. That is this form. Now we will subtract from one to another. So 2a minus 2 is 0. Here d times 2k1 minus k2 is plus 307. So d into k is equal to 370. So the only possible value of d is 370. Before moving to the question number 59, we will see the question number 60. How many four-digit numbers that are multiples of 4 can be formed using the digits 1, 2, 3, 4, 5, considering each digit at most 1? If any number is divisible by 4, its last two digits should be divisible by 2 and so in this case, these are the four possibilities. 1 to 12 is divisible by 4, 24 is divisible by 4, 32 and 40. These are the four possible numbers. If you consider 42, 42 is divisible by 2 but is not divisible by 4. So this is not possible. So the only possible values are 12, 24, 32, 40 as the last four digits. So one possibility is keeping 1, 2 as last two digits. We can make 6 numbers under these conditions. The first two digits are 34, 43, 54, 4, 45, 3, 35, 50. There are 6 possibilities, but this is for 12. Similarly, we can make 6 numbers for 24 as well as for 32 and 44. Therefore the four possibility, four chances we can make 6 numbers. So the answer is 4 into 6, 24. So answer C, that is 24. How many solutions does the equation this have? So this is question number 59. So here the idea is remove the modules, last modulus. Modulus is always greater than or equal to 0. So when you take the modulus, that number is always bigger than or equal to 0. But when we remove the modulus, so say mod A is equal to 5, when you remove the modulus, you have to put the plus or minus sign in front of this number, plus or minus 1. So when first we cut that last modulus, then that gives plus or minus. You have this minus 1 take to the right hand side, that is equal to plus 1. So now the value is this modulus is equal to 1 plus 1 2 or 1 minus 1 is equal to 0, 2 or 0. 2 is positive, 0 is a non-negative number. So modulus can be greater than or equal to 0. So now this is over, no? Now modulus. So now we remove this second modulus. You have to put the plus or minus sign. Plus or minus 2. 0 is 0 has no sign. Take this negative 1 to the right hand side as plus 1. So that gives 2 plus 1 3. 1 minus 2 minus 1 and 1. Minus 1 is not possible because that's a negative number. So only we have two choices. Then thirdly we remove this modulus. Take that negative 1 to the right side plus 1. And is that correct? And before moving this one, we have to put the plus or minus sign. When we remove the modulus, we add plus or minus. Now add this plus 1 here. That is equal to 3 plus 1 4 minus 1 plus minus 3 plus 1 minus 2. 1 plus 1 2, 1 minus 1 0. Minus is not possible because again modulus is a positive one. So 4 to 0. Now we remove the other modulus. Then you had to put plus or minus sign here. Plus or minus, plus or minus. Then take that one to here. That is 4 plus 1 5, negative 4 plus 1 negative 3, 2 plus 1 3, that is minus 1 plus 1. This is not possible. Minus value because again we have the modulus. So that now we cut the last modulus. That is plus or minus 5, plus or minus 3, plus or minus 1. Add that one to the right side, then x is equal to x has 2, 4, 6 values. Altogether 6 possibilities. So the answer is C. So these are the answers for the question number 51 to question number 60.